Hi, welcome to today's notes. I'm going to try something different. Try something with a ladybug to take notes today. So go ahead, have your notes out. We're going to talk about slope-intercept form of a linear function, okay? And there's a little bit of review in there too. The first thing that we're going to do is we are going to take a look at this line. The linear function f of x is shown in the graph, and we're going to evaluate f of 2 and f of what? F of 1, and figure out what two coordinate points they correspond to. So just a reminder of what we're going to do is we're going to find f of 2. So f of 2, we're going to go left 2, and so it intersects right here at the grid lines, and so it intersects at -1. So we'll go ahead and write down f of 2 is equal to -1. We can also write it as an ordered pair of -2, -1. Okay, the next thing we're going to do is f of 1. So we're going to go right 1, okay, on our x-axis, and then we're going to go up to where it intersects on our graphed line. We're going to go up 1, 2, 3, 4, 5. Okay, so now we have f of 1 equals 5. We can rewrite that as the ordered pair 1, 5. Okay, the next thing that we're going to do is talk about how we calculate the average rate of change. I'm going to try and focus in here real quick, see if this helps. Okay, the average rate of change of f from x equals -4 to x equals -2. And then we're also going to answer the question, this is also known as what quantity for this line. Okay, so to calculate this, what we're going to do is at f of -4, so 1, 2, 3, 4, we're going to find that ordered pair. So we're going to go all the way down 1, 2, 3, 4, 5 to -5, okay? The first thing we're going to do is, set up this equation, okay? So the way we are finding is we're going to remember that the change of y is over the change of x, and then we are finding the difference between our 2 points. So it is f of -2 minus f of -1, which is -2 minus -4. Someone asked me, does it matter which one comes first? Actually, it does not matter. The key thing is making sure your x-coordinate and the corresponding y-coordinate are on top of one another. Okay, and so that's why it's set up this way. And then, like I said, when we found the points, f of -2, we already know that from all the way up here is -1. F of -4, I found that just a few seconds ago, is -5. So I made my substitutions, and my next step, we're going to start simplifying. So -1 minus -5, that's going to be -1 plus 5. Down here, minus a negative, we have plus a positive, so -2 plus 4 is 2, and we have 4 over 2, which is equal to +2. Okay, and what is this also known as? Hopefully you guys realize it's also known as the slope of a line. Our next question, we're going to do the same thing, is we are going to be calculating the average rate of change of f of 2 from x equals -2 to x equals 1. What do we know about this function's rate of change? So, same thing, we're going to set this up. You don't have to write this every single time, but we're going to remember that it is known as the change of y over the change of x. We're finding the difference of f of 1 minus f of -2. Our x-coordinates is 1 minus -2. Okay, so these minus, it's a part of the formula for finding average rate of change. Then we make our substitutions. We'll come up here. We'll find f of 1. F of 1 is positive 5. I'm sorry. 1, 2, 3, 4. Yes, it is 5. And then we're going to, and again, we discovered that earlier, f of -2 is -1, so we make our substitutions. So 5 minus -1 over 1 plus 2. We're going to start simplifying. Minus a negative is plus a positive, so we have 5 plus 1 is 6, 1 plus 2 is 3, and we get 2. What I want you guys to pay attention to is notice that these two slopes are the same. And so what do we know about this function's rate of change? Well, first, what function is this? We have a function of it's a straight line, so this is a linear function. Linear functions have a constant rate of change, and we know that because we are getting the same slope when we calculate. So make sure you have this copied down. Then the next thing we're going to do is we're going to talk about, for a linear function, the change in y to the change in x is also known as the line slope. So you'll hear me talk about both the average rate of change and slope. They are the same thing, okay? There's a form, or like a formula, or kind of an equation. Officially, it's called a form, but a lot of times it's an equation called slope-intercept form of a line. Okay, right here. F of x is equal to y, which is equal to mx plus b. So, again, given a linear function, we either write it as f of x or we write it as y, but we set it equal to mx plus b. Some key things that we're going to remember about this is that m is our average rate of change, okay, which is the change of y over the change of x, and we just practice that in part B and part C. And then b is the y-intercept of the line, okay, and we're going to do some examples here. We are given g of x is equal to 1/2 x plus 1. We're going to do the following. What we're going to do is we're going to create a table, and then we'll graph it. When we create our table, a couple of key things. First, you have to have 0. Okay, make sure that's all on there. Next, you have to have 5 points. Now, the other 4 points that I chose points that are divisible by my denominator. Okay, we're going to be doing all of this without a graphing calculator. Okay, so our graphing calculators are going to take a break probably for most of this unit. So we're going to we can do some mental math, put -4 in for x, and simplify from there. So 1/2 times -4 is -2. -2 plus 1 is -1. Then we're going to do the same thing where we'll put 1/2 in for -2, which gives us -1. -1 plus 1 is 0. We put 0 in for x. 1/2 times 0 is 0, plus 1, we get 1. We're going to put 2 in for x. 1/2 times 2 is 1. 1 plus 1 is... Did I do my math wrong there? I have 4. That's not right. That has to be 2. My bad. And then we put 4 in, so 1/2 times 4 is 2. 2 plus 1 is 3. Okay? And then the next thing we're going to do is we're going to graph this function. When I graph this function, we're going to just take these ordered pairs. So -4, -1. So I start on my origin, and I go left 4, 1, 2, 3, 4, down 1 for -1. For -2, 0, same thing. We go left 1, 2, and it stays right there. 0, 1. So we stay on the y-axis. 2, 2, we go right, 1, 2, and up 1, 2. And right 4, up 3. And then we have all of our points graphed. You're going to use some sort of straight edge and connect those lines. So we're going to illustrate the slope of the function graphically. And I will say you guys will be needing a ruler to graph part B. What I mean by that is we're going to find a point on our graph. And we are going to use our slope to get from one point to the next. And so we always do the change of y, so up or down first. So in this case, we're going to go up 1, right 2. Okay, and you see I have that already right here. Up 1, right 2. The last thing, part D, is circle the graph's y-intercept. Circled right there. There's a quick way of graphing besides creating a table. Key thing for the quick way of graphing is understanding plotting your y-intercept and to be able to do our slope. So again, up 1, right 2, up 1, right 2, up 1, right 2. And we can continue that pattern. Okay, let's flip our notes over. We're going to do the same thing for number 3. Number 3, we're going to create a table of 5 points. We have g of x is equal to negative 2/3 x minus 2. When we create our 5 points, we're going to make sure we are choosing values that are divisible by 3. Okay? So the values that I chose, negative 6, negative 3, 0, 3, 6. Again, you have to have when x is 0. That is a given, no matter whether it's divisible, you're working with a fraction or not. Okay, so same thing, we're going to put negative 6 in for x, simplify and solve. Okay, so this is all mental math. So negative 2/3 times negative 6 is positive, minus 2, we get a positive 2. Then negative 3 times negative 2/3. Okay, making our substitutions. We have positive 2. Positive 2 minus 2 is 0. We put 0 in for negative 2/3, which gives us 0. Then we get negative 2. We put 3 in for negative 2/3. We get negative 2. Negative 2 minus 2 is negative 4. We put 6 in for negative 2/3. We have negative 4 minus 2 is negative 6. You're going to take this information and plot the points on your coordinate plane. So we do with our first ordered pair, negative 6, go left 6, up 2. Then negative 3, left 3, 0, we don't move. 0, negative 2, okay, we don't go left or right, we just go down 2. 3, negative 4, so right 3, down 4. And positive 6, down 6. We're going to illustrate the slope of the function graphically. So I can start at my y-axis. Because it's negative, that means we're going to go down 2. We're going to write that in, down 2. And then we go right 3. Again, down 2, right 3. Now what I didn't talk about is you can also do the opposite. So if we're going to go up, then we go left. So a down or a left movement is a negative movement. Okay? So a lot of times we always start going up or down first. I like going down because it's negative, so down 2, right 3. We're going to circle the y-intercept as well. I'm going to have you do number 4 on your own. And let's jump down to number 5. So again, 4 is on your own. And we're going all the way down to number 5. So on number 5, we're going to use the information about slope and y-intercept to graph y equals negative 3/5 x plus 4 on the grid. We're going to pick 2 points off the graph and calculate the average rate of change and verify that it's equal to the slope. So the first thing that we're going to do is we're going to use our information that we know about y equals mx plus b. We know that the y-intercept is 4, a positive 4. We also know that m equals negative 3/5. What that means, the negative means down 3. Since there's no negative in front of the 5, it's right 5. And this is how we're going to plot our points. We're going to start first with our y-intercept. So we start at the origin. We're going to go up 1, 2, 3, 4. Okay? You plot that point. Then our slope is down 3, right 5. So we're going to go down 1, 2, 3, and right 5. 1, 2, 3, 4, 5. Okay? Now again, I just showed you a little bit ago that you could do the reverse, where if we are starting at the y-intercept, we can go in the opposite direction. So instead of going down, we go up. 1, 2, 3. But then we apply the negative to our 5, so we go left. 1, 2, 3, 4, 5. Okay? And so draw your straight line. Make sure you're using arrows. So from here on out, if we're not using arrows, we're not making nice big lines, you will be losing points. So hopefully that does not happen to you. That's the bell for you. The last thing that we're going to do is we're going to find the average rate of change. We're going to pick 2 points. So I'm choosing -5, +7, then +5, +1. When we do this, the change of y over the change of x, so we're going to do 7 minus 1 or 1 minus 7. But since I wrote 1 first, I'm going to have to use that x ordered pair and put it right underneath. Okay? And so for 7, its x ordered pair is -5. So that's going to go right underneath our formula. We have the minus. Then we simplify. 1 minus 7 is -6. 5 minus -5 is +10. And our simplified fraction, -3/5, which is from our original equation. There you have it. Okay? That's it for these notes. I'll see you guys next time.